So in this video, we've been asked to prove the square root of 3 if it is an irrational number. So there are different rules that applies when you're doing this and when you're solving this. So let's solve the question. You start first. So this question can only be solved by contradiction. So you first of all you say proof by contradiction. So we're going to contradict our statement by assuming the square root of 3 to be rational. But the question is saying we need to prove that it is irrational. So proof by contradiction, we're going to prove that the square root of 3 is rational. So we're going to say assume the square root of 3 is rational. If it's rational, therefore, the square root of 3 can be expressed in the form of a over b, where a and b are members of integers, then b must not be equal to 0, and I'm not supposed to put this and, then a and b must not have a common factor. After writing this statement, it's very important. So we assume that the square root of 3 is rational. Therefore, the square root of 3 can be expressed in the form a over b. A rational number is a number that can be expressed in this form. Then a rational number, we can't place it in that form. So I've said that then a and b must be the member of integers. Remember, z is representing integers. Then if you look at a over b, then b must not be equal to 0. Meaning we can't, if it's equal to 0, then we will not be able to express the rational number in this form because it will be undefined. Then a and b must not have a common factor. In other words, they're going to say a and b are co-factors. So from there, after writing this, then we do what our statement has said. We say square root of 3 is equal to a over b. Then the next step, you square them. When you square the square root, it means you're just going to obtain the same answer, the same number, then here over b. Also b must be squared. Then here we can do the multiplication, where we're going to obtain a squared is equal to 3b squared. Now, when you have this simply means that when you multiply 3 times b squared, you're going to obtain a squared. So for us to obtain b squared alone, we need to divide a squared by 3. This statement simply means, therefore, a squared is, you can write it is a factor of 3, or it is divisible by 3. If a squared is divisible by 3, then even the a itself is divisible by 3. Therefore, after writing this, then a can be equal to 3k. You just take this and replace since we have this equation here, then after writing this statement here, we can now write it in the form of A. We take, now since A is divisible by 3, therefore we can say A is equal to 3 times any letter of your choice. So here I'm picking K. That's where the K is coming from. Don't get confused. Why is the K coming from? You can just, since we're saying it's divisible, so we need to multiply 3. Since we have said A is divisible by 3, so if we multiply 3 by any letter to give us A. So I have chosen my K. You can put X if you want. You can put P if you want. Some of you like X's. That's why you always go back. Sorry. Let's continue. So after writing this, then you can also take now this equation. You can take this part, equate it to this part. But remember, you need to square it as well, since it's squared. So we're going to say 3K squared is equal to 3B squared. Then you have 9K squared is equal to 3B squared. Now, after having that, you can now divide. If we divide, we're going to obtain something like B squared. Now look at, we have something which is more like what we had here. Then we write the same thing. Therefore, B squared is divisible by 3. This entails us that also B itself is divisible, or it's a factor, can replace divisible by a factor of 3 now by 3. Now from we write the statement, initial assumption, we said A and B must not have a common factor. This is what we said here. Now, if you look at what has happened here, we're having a common factor. A and B, they're having the same common factor. A and B are having a common factor, which is 3. Now, from our initial assumption, we said that A and B must not have a common factor if square root of 3 is rational. Then this contradicts our initial assumption. Then square root of 3 is it is irrational. Hence proven. Thank you.